how can I measure the concentration of this solution? Well, a spectral photometer can measure the concentration of a solution for me. But the way a spectral photometer works is that they use light to measure the concentration inside the solution. So here we see a highly concentrated solution, and what's gonna happen is that a certain amount of light is gonna pass through the cuvette, and then the spectral photometer reads the output of how much light came out. And because of this, certain light particles are gonna get stuck inside of the cuvette, so we'll have a different reading than from the beginning to the end. And in a low concentrated cuvette, we would have a higher reading of light molecules. Therefore, the spectral photometer can measure the concentration for us.
So in order to use the spectrophotometer, we need to download an app. So I'm going to open up the App Store and search Spectral Analysis. And the first result is Vernier Spectral Analysis. That's the app we're going to use. So I already have it downloaded. I'm just going to open it up. And when I open it up, the first thing I want to do is click Connect a Spectrophotometer. And if your Bluetooth is on and your spectrophotometer is on, it'll automatically pop up, and you're just going to click Connect. And once connected, you'll have all of these different options for things that you can record data for. For now, I'm just going to click on Advanced Full Spectrum just so we can see everything. And the first prompt is going to be to calibrate the spectrophotometer, and so I'm just going to go ahead and calibrate it. And this is just all to get the app set up to use. And so now that the spectrophotometer is calibrated and connected, we have a whole bunch of different features that we can use. If I click the graph on the left, it'll give me the option to apply a curve fit, which we'll use later. And you can also toggle on the graph legend if you have multiple things that you're graphing and you want to differentiate between them. If I click the three dots in the top right and click on App Preferences, I can change the scale of the graph to zoom in or out. I also have the option, if I click on the table in the top right, to add additional graphs. And with these graphs, I can change the variables on the X and Y axes. And I also have the option to add additional columns to the table. Manual columns are data or information that you input yourself, and then the calculated columns allow you to insert expressions or equations, and it'll do calculations for you depending on the data that the spectrophotometer records. And finally, if I click on the file in the top left and click Export, I have the option to save the graph to files or onto the computer.
So the spectral photometer could be accessed through the phone or the computer, and what you want to do is you want to search up spectralanalysis.app, and it's gonna take you straight away to the app. And once we're here, we want to select Connect the Spectral Photometer, and you can either do this wireless or USB. And here we're given the option to connect it Bluetooth by pressing the button on the side. So we're gonna connect to the spectral photometer. Once the spectral photometer is paired, we're gonna get this prompt and we're gonna click absorbance and concentration. And we need this because we're gonna determine the concentration of our cuvettes. Okay, so when we're prompted to select something, we want to select the best optimal wavelength for our cuvettes. And right now we're using yellow cuvettes, so the best optimal wavelength for these yellow cuvettes will be 429 nanometers of wavelength.
In order to figure out the concentration in this solution, we have to have a standard curve to compare it to. So we have 3 solutions of known concentration that we can use to create our standard curve. So in order to do that, we're going to go to the app and we're going to select collect, and that's going to start collecting data points. And right now we still have the cuvette that we used to calibrate the spectrophotometer in the machine, but we're going to take that one out. And we're going to input our first solution. So you just put it in like that, and then you'll see that the app reads the absorbance. So now that we have this solution in, we're going to click keep, and that's going to collect this data point. And we know that this solution has a concentration of 0.0005 moles per liter, and we're going to select keep point, and that's going to start the plotting our graph. And so now we have these 2 other solutions. The next one has an absorbance of 0.136. We're going to keep that data point. And that one has a concentration of 0.0006. And then we have one more. That has an absorbance of 0.283. We're going to keep that data point. It has a concentration of 0.0008. And so now we want to create the curve. So we're going to toggle to this option here that says graph options. And when you click on it, it says apply curve fit. We're going to click that. And we want it to be linear. We're going to hit apply. And this is going to create for us the line of best fit. It shows you the equation of the line. And this is what we're going to use to figure out the concentration of our unknown solution. Okay, so on here it tells us the equation of this best fit line. It has y equals mx plus b, where it gives us the slope and the y-intercept, and it also tells us the correlation coefficient, so we know how good the data is, and that's pretty close to 1, so we know that this is pretty accurate. And now we can take our unknown sample and put it into the spectrophotometer, and it's going to read the absorbance. And what we can do is, because we know that this is our y value, we can plug this absorbance into the equation, and we can solve for x, which is the concentration of the solution.
So now that we have our line of best fit, we can plug in our value for our absorbance, which is 0.269. And what we don't know is the concentration. Our concentration is in between this value. So what I'm going to do is I'm going to add 0.1814 to both sides, and it's going to give me 0.4504 is equal to 570.1x, and we're going to divide both sides by 570. So then our concentration would be equal to 0.0008 moles
Per liter.
per liter.
Some pros of the Vernier spectral analysis app are that it is easily accessible. You can search it up in your browser or download it for free in the App Store. Device pairing is also easy. You can connect via Bluetooth or using a USB if you're on the computer. And setup and calibration takes less than 5 minutes to do. And once actually connected, minimal effort is required by the user, because once you click collect data and you just click like keep this point, it starts to generate the graph for you and also the equation of that graph. And a couple cons of the app are that you have to have solutions of already known concentrations in order to generate that standard curve. And so knowledge, like prior knowledge, is required. And also the device has high sensitivity, which is good in that it's more accurate, but also if your cuvettes have any fingerprints or any type of residue on them, it's going to impact your results and give you inaccurate data. Overall, we give the Vernier Spectral Analysis app a rating of 4 out of 5 stars for its user-friendliness and for serving the purposes of our lab, but we took a point off for the fact that you have to actually have a spectrophotometer handy, and you have to have solutions of known concentrations, which you might not have readily available. And so for the fact that that's slightly impractical, we take a star off.